Today, we'll explore linear equations in one variable, focusing on verbal equations. In this video, we'll break down word problems and learn how to translate them into linear equations. Word problems may seem tricky at first, but once you understand how to convert them into equations, they become much more manageable. By the end of this video, you'll have the skills to solve these problems and turn words into numbers confidently. Here's what we'll cover today. First is how to identify key information from a word problem. Next is how to write a linear equation from that information. And finally, we'll solve some examples, starting with simple problems and gradually moving to more complex ones. Let's dive in. Now that we've introduced the topic, let's break down what we mean by verbal equations and how we can solve them. A verbal equation is simply a word problem that describes a mathematical relationship. Our job is to translate the words into an equation that we can solve. This process involves identifying the key information from the problem and deciding what the unknown value, our variable, should represent. Here's the key idea. When you see a word problem, look for clues in the form of numbers, relationships like more than or less than, and keywords like total or difference. These clues will help you form the equation. For example, Tom has 3 more than twice the number of apples as Sarah. You could represent Sarah's apples as x, and Tom's apples as 2x plus 3. Remember, once you've solved for the variable, always check your solution by plugging it back into the problem. Let's take on our first example. Tom has 3 more than twice the number of apples as Sarah. If Sarah has 5 apples, how many apples does Tom have? Let's break this down step by step. First, we need to identify the key information from the problem. The problem already tells us how many apples Sarah has, which is 5. Now, let's focus on how Tom's number of apples relates to Sarah's. The problem says that Tom has 3 more than twice the number of apples as Sarah, so we'll start by multiplying Sarah's apples by 2. Then, the problem says Tom has 3 more than that. So we'll add 3 to 10. Finally, Tom has 13 apples. Let's take a look at another example. A cable company charges a monthly fee of $40, plus an additional $5 for each movie rented. If your total bill for the month was $85, how many movies did you rent? First, we need to identify the key information. The problem tells us that the monthly fee is $40, and each movie rented costs $5. We also know the total bill was $85. What we need to find is how many movies were rented. This will then become our variable. Let's call this value x. This means that the total cost for renting movies would be $5x. But the total bill of $85 wasn't accumulated solely by the number of movies rented, as this number also includes the monthly fee of $40. So the equation for the total bill is as such. Next, we'll solve this equation step by step. First, subtract 40 from both sides to isolate the movie rental term. Now, to find x, divide both sides of the equation by 5. So, the customer rented 9 movies this month. Let's now discuss a more challenging example. A concert ticket costs $30 each, and there is a one-time service fee of $15. If you paid a total of $165 for your tickets, how many tickets did you buy? First, identify the key information. We know that each concert ticket costs $30 and that there is a one-time service fee of $15. We also know the total amount paid was $165. What we need to figure out is how many tickets were purchased. This will then become our variable. Let's call this value x. This means that the total cost for the tickets would be $30x. But the total bill of $165 wasn't accumulated solely by the number of tickets purchased, as this number also includes the one-time fee of $15. So the equation for the total bill is as such. Next, we'll solve this equation step by step. First, subtract 15 from both sides to isolate x. Now, to find x, divide both sides by 30. So, the customer bought 5 tickets. Let's check our answer by substituting x equals 5 back into the equation. That checks out, so the correct answer is 5 tickets. Great job working through these verbal equations today. Let's quickly recap what we've learned. Today, we learned how to translate a word problem into a linear equation. This is the key skill for solving verbal equations. This starts with identifying the variable, where we figure out what we're solving for. Next is setting up the equation, where we looked for specific keywords to write relationships between quantities. Last is solving, where we utilized algebra to find the solution. The key formula to remember is the fixed cost plus the product of the variable cost and the number of items equals the total cost. When applied, that looks like this. Well done today, and keep up the great work. We'll see you in the next lesson.